Hi friends, welcome back. Today we are going to solve another very important and recent coding interview question 2457, minimum addition to make integer beautiful. As you can see, this is quite a popular coding interview problem on Leetcode. This is a medium complexity coding interview question. This is also very recent problem. So we are going to go through this problem today. We are going to solve this problem and implement our Java solution code to solve this coding problem. If you are a fresher, junior level developer, mid-level developer trying for interviews, then make sure you watch this video until the end so you completely understand the logic as well as the Java solution to solve this coding problem. This is an important coding problem. Before we start looking into the details of this problem with few example and the explanation of the logic, I would like to quickly mention that this channel is to help people in their coding and Java interviews. On this channel, you will find more than 500 different varieties of coding problems solved and explained using whiteboarding sessions, examples and Java code. Many of those problems are taken from previously asked coding questions by big tech companies including Google, Facebook, Amazon, Apple, Microsoft, Yahoo, Uber, Lyft, LinkedIn and many others. Among those solved coding problems, you will see all important coding questions varieties are covered in them. That includes problems related to graphs, matrices, binary search trees, binary trees, different data structures and algorithmic problems including stacks, queues, priority queues, hash table, hash map, tree set, hash set, linked hash map, linked hash set, as well as many more important data structures and algorithmic problems. So if you are preparing for any coding rounds of interviews or Java rounds of interviews, or you simply want to learn different concepts of computer science, programming, data structures, algorithms, problem solving, logic building and Java coding, then this channel can definitely help you in doing so. So please subscribe to this channel now. So let's start with this 2457 minimum addition to make integer beautiful. You are given two integer numbers n and target. An integer is considered beautiful if sum of its digits is less than or equal to the target. Return the minimum non-negative integer x such that n plus x is beautiful. The input will be generated such that it is always possible to make n beautiful. Okay, so they have given constraints is n will range between 1 to 10 raised to 12 inclusive, so n can be very large number as you can see, and target will range between 1 to 150 inclusive. The input will be generated such that it is always possible to make n beautiful. Okay, so let's take a look at this first example. So 16 is the number that's given to us. Our target is to bring the sum of these numbers digits less than 6, right? So it should be less than or equal to, right? Less than or equal to 6. So right now the sum is 7, right? 16 means the sum is 7 for 16, right? So now if you go to 17, the sum will be 8. Our target sum is 6 or less than 6, right? So target should be 6 or less than 6. So now if you go to 18, then your sum will be 9, correct? If you go to 20, your sum will be 2. How we are calculating the sum? Sum of the digits, right? 1 plus 7 is 8, 1 plus 8 is 9, 2 plus 0 is 2. So now we got a number basically 20, right? 20 we got a number which is having less sum than less than or equal to 6, right? So how much we have added actually in the original number? We have added 4 into the original number, right? So that's what we have to output, as you can see here, right? This is what we want to output and find out. So they are saying that minimum addition we have made actually into that number, so now it became beautiful, right? Okay, so you got the idea. So this is another big example over here. So let's understand with this example now. So now if you take a look at this number 467, the minimum number that, and this sum is 4 plus 7 is 11 plus 6, right, is 15, right? No, 4 plus 7 is 11 plus 6 is 17. So sum is 17. Now we want to target sum is 6, so we have to bring it down. Our purpose is to bring the sum of the digits down, correct, so that it will be less than or equal to this 6. Right now the sum of the digits is 17. So when will the sum will get down? If we can convert these digits into 0, then the sum will get down basically. You got it, right? So if we convert these digits into 0, then the sum will get down basically. It will come down basically. For example, if I put 0 instead of this 7, right? And if I'm putting 0, obviously the numbers we will be looking for will be bigger than this number. So what is the number where I can put 0? The next number I can put 0 is 470, correct? You see, right, what I'm saying? So this number should be bigger than this previous number, and we are trying to convert the digit to 0 so that the sum will come down. Now the sum will become 11. Sum came down, as you can see. The sum was 17 before. Now the sum is 11, so it came down, and it came down maximum basically, right? It will come down maximum when you convert this digit to 0, correct? So the sum is 4 plus 7, which is 11, then 4 plus 6 is this 17, right? Okay, so now next time if we want to again bring it down, because still this sum is not acceptable, right? We want something less than or equal to 6. So now what we have to do, again we'll try to convert this 7 into 0. So this one, if I put 0, then what do I have to do? Then the next choice we have is put 5 here, right? I have to put 5, correct? Then only I will get 0 here. You got it, right? Okay, so now if we do that, then what is the sum? Sum is 5 now, which is acceptable. It's less than or equal to 6, right? So this is the minimum number we have actually found, which is a beautiful number. So how much did we add into our original number? So 467 was the original number. Our right now the number is 500, right? So we have added 33 into the original number, correct? And now it became beautiful, correct? This is the minimum number of addition we have to do. You cannot make anything less than this. You got it, right? And why we are why will this approach work? This approach will work because we started greedily choosing a digit from right side, right, which is the least significant digit. Basically this is the least significant digit, correct? Right? So it means that the number that we are going to find at the end is going to be the minimum number, or minimum beautiful number basically, right? Minimum beautiful number which is greater than this number, right? You got it, right? So this is how the solution will work. So now what we have to do now, so let's one more time we'll go. So now this one, we know that this is the original number that's given to us. The sum is 17. So finding sum is very easy. We'll write down one function which will give us the sum of the digits, right? It's very easy. So how that sum function will work? So let's say so you will take a mod of 10 basically, right? You will take mod of 10 here, okay? Then you get 7, correct? You get 7. So let's put 7 here. Now you will divide this number by 10. So if you divide this number by 10, you get 46. Again you calculate mod of 10. So mod of 10 will give you 6. Now you add 6 plus 7 plus 6, right? Now again you divide this 46 by 10. So if you do it by 10, then you are going to get 4. Again if you calculate 4 mod 10 is going to give you 4. You are going to add this 4 into this. So you are going to get 17 at the end, right? So this is going to give you the sum. Now if you divide this 4 by 10, it will be less than 0, right? So less than 0. So we'll stop there. So this is how you can calculate the sum of the digits. So we'll write down a function for this. That will, you pass a number, it will calculate the sum of the digits. So that is easy. So now our approach, as we discussed, is we'll take this number, okay? We will always go to the, so now this sum is obviously greater than target, so we have to bring it down. So we'll always choose the rightmost digit. So this digit we want to choose, and let's call it like a rightmost digit. Let's say rightmost digit, okay? We'll create one variable rightmost or something, which is 1 in the beginning, okay? This is 1. So we'll go here, we'll make it 0. Once we make it 0, then this number should be changed to 470 basically, correct? 470. So how we will change it? What we will do is we will calculate 10 raised to this 1 minus 1 plus basically 10 minus 7 we will calculate, right? So you will get basically 10 minus 7 is 3. So you will add 3 into this 467. So you will get so this one is multiplication, I'm sorry. So this is multiplication, okay? So 1 multiplied by 3 is 3. So you will get 470, correct? So 467 plus 3, 470, okay? Now next time This one sum is 11, so it is still not acceptable because our target is less than equal to 6. Again we have to, now rightmost digit will be increased by 1, so now it is 2, so we will go here. So now it means that we have to convert this 7 to 0. So this is already 0, we'll convert it to 0. So if we want to convert it to 0, we have to make 5, this one to 5, right? How we will know, how we will calculate that? We will go to this 7 and again we will do the same thing, right? So 10 raised to this rightmost digit 2 minus 1 multiplied by 10 minus 7, correct? So 10 minus 7 means this digit, basically this digit, okay? 7 means, so this digit 10 minus, this is 3, this is multiplied by 10, right? 10 raised to 1 is 10, so it will give you 30. So this 30 you will add into 470, so you will get 500. Again you use our function to calculate the sum of these digits, it will give you 5. Now this one is acceptable because this is less than or equal to the target. So now we got a number which is a beautiful number, right? So we have to just calculate the difference between this beautiful number and our original number 467, right? So it will give you difference which is 33, right? That we have to output. So this is how we will solve this problem. So I hope it is clear to you now how we have used this logic to solve this problem. So we'll create one variable rightmost digit, it is 1 in the beginning and it will keep incrementing every time, basically, right? So this is 1 here, then it will become 2 here, then it will become 3 here, like this, right? And then 10 raised to rightmost digit minus 1 multiplied by that 10 minus rightmost digit, correct? So this one addition we have to do to this number, so we'll get the next number that we want to try, right? The next number we want to try is 470, the next number we want to try is 500, like this, right? So the important thing is we are choosing this last the rightmost significant digit, so right, this one, and we are converting it to 0, so that we have to add minimum number of addition, basically, correct, into the original number to get the to make it most beautiful integer, right? So this is how we can solve this problem. So I hope it is clear to you with this example and explanation. So we'll go to the code, so it will be more clear for you once we go through the code. So before that, we will before we go through the main method, I'll show you the get sum method. So as I shown you, like as I said, we want to calculate the sum of all the digits. So what we will do, sum is 0, while n is not equal to 0, we will first calculate the last digit, right? N mod 10. We get the last digit, then we'll add that last digit into the sum, and n will be n divided by 10. So we'll keep doing this. So this is what I shown you here, right? This is what we saw here. So we want to calculate the sum of 4, 6 and 7. So this is how we can calculate that sum. So it will keep looping until n is not equal to 0. Once n is equal to 0, we'll just return the sum, right? So this is the helper function that we will be reusing into the main method. So our main method is this one, make integer beautiful. So it's going to return long, we are going to get input as n and target, right? So two things we will get here as input. So n is the number and target is the target, right? The 6 is the target in this case. First thing we will do is we will calculate the sum of the current number, right? The sum of the digits of the current number, like this 17, right, is the sum of the digit. So we'll get that sum. If this sum is less than or equal to target, then we don't have to add anything, basically, correct? If the sum is less than equal to target, we don't have to add anything, so we'll just return 0 in that case. So this is the basic check we will do. Now after that we have to do this logic that we discussed, right? So original is equal to n, the bit right position is 1, correct? The bit right position is 1, so this rightmost is the same, basically bit right position, it is 1 in the beginning, correct? So while sum is greater than target, we will have to do this, right? Because we want the sum to be less than or equal to target. So while it is greater than target, we will do these steps. So we will create this, get the bit right position digit from the right, correct? So I'll just explain you here again, so it will be more clear. So this part is clear to you, that 17 part, right? So we got 17 sum here. So this is fine. So this is the rightmost digit, correct? The rightmost digit is 1 right now. So we want, this is the rightmost 1 digit, basically. This is rightmost 2 digit. This is rightmost 3 digit. Okay. So rightmost digit is 1 is 7. So we have to find out how we will find out that 7. Like this we have to find out. So n mod mat dot power of 10 multiply 10 raised to bit right position divided by 10 raised to bit right position minus 1. Correct. So basically you are doing like the 10 raised to bit right position minus 1, correct, multiplied by 10 minus 7, basically, correct, 10 minus 7. So this is what you are doing, right? 10 bit right position minus 1. Okay, so 10 raised to 0. So essentially your n mod 10 raised to this one is 10 raised to 1, which is 10 raised to 1 is 10, and divided by 10 raised to 0, correct. 10 raised to 0 is 1 and 10 raised to 1 is 10, right? So n mod 10, so this mod 10, if you do mod 10 you will get 7, right? So 7 is the digit basically, right? So 7 is the digit, right? Okay, so now you got that 7 digit here first. Okay, the last digit you got, last bit means last digit you got from that number. Now we are calculating the what we have to add there so that we can convert this 7 to 0 now, right? We want to convert this 7 to 0, so we have to add 3 into this number, right? So that how we will calculate it, this is how we will calculate this. So 10 raised to bit position minus 1 means 1 minus 1 is 0. So 10 raised to 0 is 1, right? Multiplied by 10 minus 7. So 10 minus 7 is 3. So 1 multiplied by 3 is 3. So you will add that 3 into n, correct? Okay, so 467 plus 3 is 470. So you will get 470. You will increment bit right position by 1. So it was 1 before, now it will be 2. And your number now became 470, correct? So 470 is number. So you converted this 7 into 0, right? So here you have converted it. Now you will calculate the sum of this new number. The sum of this new number is 11. Still it is not less than or equal to 6. So we have to again do the whole process again, right? Again you will calculate the rightmost position 2. The rightmost position 2 is 7, right? So you will again calculate that position 7. You will get that digit 7, correct? Same thing you will do here. n mod you will do 10 raised to 2 this time, which is 100. 100 divided by 10 10 raised to 2 minus 1. So 10 raised to 1, right? So 10 raised to 1 is 10. So n mod 10 basically, right? N mod 10. So n is what? 4470. Mod 10 is what? 47, right? No, sorry. 47 mod 10, right? 47 mod 10. So it will give you 7 basically, correct? So 10 raised to bit right position. So now bit right position is what? 2. Okay, so it is going to give us 100 here, and divided by 10 raised to 2 minus 1. So 10 raised to 1 is 10. 100 divided by 10 is 10. So n mod 10 is, the last bit will be 0 then, correct? And then you have to calculate this. N is equal to n plus 10 raised to 2 minus 1 is 10 raised to means 10 multiplied by 10 minus last bit. So last bit here is actually last bit is 7 here, right? 7 is the last bit here. So 10 minus 7 is 3, right? So 10 multiplied by 3 you will get basically. So you have to add 30 here, essential, right? 30. So it will become 500 after you add 30, correct? So this is how you will get 500, and bit position will be incremented, and sum you will again calculate. Now your sum will become 5 here, right? And your bit will be 3 next time, right? So 5 means you will stop because your 5 is less than or equal to 6, right? So this is the number that you found out, which is a beautiful number, and it is the smallest number now, which is beautiful number and greater than 467, right? So you have to find out difference between 500 and 467. So this way you can solve this coding problem, right? So I hope it is clear to you, this logic. So every time you will have to find out this rightmost significant digit, right? So first it will be 7, next time again you come here, it will be again 7, like this, right? And then you have to just add it into the old value of n, right? So here old value of n is 470, so you calculate 30, so you add 30 here. First you calculate 3, you add 3 here, right? Then 30, so 30 add, you will get 500. So at this point you will just get n minus original, so it will give you the uh, difference basically, and that's what the minimum addition that you have to do so that the integer becomes beautiful, right? So this is how the code works, right? So this logic, I hope it is clear to you. This is a little bit tricky logic, but once you understand this, this is not that difficult or anything. So so this n mod, this figure, that this one you calculate separately basically. So for example, let me just remove this. When you reach to 470, we calculate SA1, right? So now when we calculate, now next time what we do is 470 is our number, correct? 470 is our number, so we are doing mod 100 here because bit position is 2, so 10 raised to 2 is 100, so mod 100. When you do mod 100 to 470, what you get? 70, correct? So you get 70, and then you divide it by 10 basically, right? 10 raised to 1 is 10, correct? So you divide it by 10. So if you divide it by 10, you are going to get the next, this right significant digit basically, the next one, correct? So this 7, you get 7 right here, and then again you calculate this remaining value that you want to add using this logic, right? So what, how we will calculate? 10 raised to 2 minus 1, so 2 minus 1 is 1, so which is 10, and 10 multiplied by 10 minus 7, so 10 multiplied by 3 is 30, so you will add 30 here, right? Okay, so now you got this idea, and I explain you why this logic works, and right, so this is kind of a greedy approach. So we always try to put 0 for every rightmost digit. So we'll convert this 7 to 0 first, then we'll convert this 6 to, means whatever the next right digit, we'll convert it to 0, right? 500 means you converted that digit to 0 basically, correct? So this is 0 0, right? Next time you don't have to do it because you already got the number which is within the target, right? So we'll now execute this code, make sure it works correctly. So let's take a look. This is the first example. We are expecting 4 as the answer. For first one we are getting 4, which is correct answer. For the second one we are expecting 33. Let's take a look. So this is the second example. We are getting 33 as the output, which is correct answer. For the third one we should get 0. So this is the third case where we are getting 0, which is correct answer. So we are getting correct answers. We'll just go ahead, submit this code to the Leetcode, make sure it gets accepted. And as you can see, the code got accepted. It is 74% faster on the performance and 6% faster on the memory usage. So this is the way you can solve this important coding problem on Leetcode 2457, minimum addition to make integer beautiful. I hope you clearly understood this approach and how we have solved this coding problem today. If you are new to this channel, we have created a very important coding interview related playlist for you to help you in your interview rounds. The name of that playlist is Leetcode and Leetcode Solutions. We have compiled more than 250 most frequently asked very important coding interview problems for you under one playlist there. You will see all different varieties of coding problems, which are very important coding questions. Those questions got asked by many big companies, including FANG companies, many times in their interviews. So those are very important coding interview problems. Make sure you go through those problems, understand the logic behind the solutions, and also understand how the Java solutions are implemented to solve those different problems. Everything is explained for in those videos with examples, so you can easily follow those examples and understand those problems. If you go through those videos, you are going to learn a lot about data structures, algorithms, problem solving, logic building, as well as how to approach and solve medium to difficult level coding interview problems and how to implement their solutions in Java. So it's going to help you learn a lot of new approaches there that you can apply, new techniques of problem solving that you can use and apply in your coding interviews. You are also going to learn a lot of Java coding there. It will help you learn a lot of new Java APIs and classes that we often need during the implementation of different concepts and different solutions. And it is definitely going to help you in your interviews. So those are very, very important problems. Check out the videos. The name of the playlist is Leetcode and Leetcode Solutions. If you are a fresher, junior level developer, you want to practice more coding problems. For that purpose, we have created 3 other major playlists for you on this channel. The names of those playlists here are Code Forces, Code Chef, Coder. Code Forces, Code Chef, Coder. All in all, more than 500 problems are here to help you in your interview rounds and your learning process. If you are a Java J2 developer, you are a junior level developer or fresher, you are trying for interviews, then for you on this channel we have created lots of helpful videos to help you in your interviews. For example, frequently asked Java telephonic interview questions and how to answer them. Java design patterns, Java architecture, SQL programming questions to the freshers, where they will give you database tables. They will ask you to write SQL queries where you may have to use different database paradigms like inner join, outer join, left outer join, right outer join, aggregate operations, group and having clauses, different ways of filtering. Everything is explained for in those videos with examples, so you can easily understand those SQL queries, and you also will be able to write those kind of SQL queries in your interviews. So check out those very important problems there. There are also videos that discusses Unix questions to the freshers. For example, Unix commands, Unix utilities, shell scripting questions, all are here to help you. If you like this video, if you find this video helpful, and if you like this logic, how we have solved this problem by this greedy approach, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Subscription is very, very important because that is the way the videos can reach to many more people. So others will also be able to watch these videos. They will also be able to learn problem solving using different data structures and Java language. So if you like this video, then do subscribe to this channel, give it a like to the video, share this video with all your friends. So your friends will also learn Java coding, programming, data structures, algorithms, problem solving, logic building, and Java programming here. I'm going to add this Java solution code in my GitHub project and give you the link of this code so you can check it out. There are lots of other important algorithms and Java solutions already implemented there and available for you. So don't forget to check out the other Java solutions. It will help you learn more Java coding there. If you like the Java solutions in the GitHub repository, consider giving it a star on the GitHub repository. That would be great. If these videos on this channel are helping your learning process, your interview preparation process, you are learning more problem solving here with data structures and algorithmic approaches, then don't forget to mention that by writing comments. Your comments are very valuable for us. That increases our motivation to create more quality content. So if this content is useful and helpful for you, then do mention that into the comments. Keep learning, keep coding, keep solving more varieties of problems, and most importantly, keep your learning process going on continuously. And thanks for watching this video.